Hello once again. So welcome to problem solving with special maths. So problem corner for February. So welcome to level 2 of the geometry problem. So this time around, we're just going to continue from where we stopped. Just going to include the circles of all those circular quadrilaterals we had in the first level. So if in case you've not seen that video already, make sure to go back to that so that you have the right context. All right, so let's move on to GeoGebra. Okay. So this is the complete diagram for all the circles we want. So there are actually 12 circles here. So we're expecting to construct 12 centers. So before we get into that, we actually constructed this diagram. And to do that, we just need to investigate some properties about the angles. Okay, so that would be quite useful for what we want to do. Actually could have used this to solve the level 1, but it's not really necessary. So we can do that now. So what we have is if you observe, we have that. So we're going to be using directed angles. So maybe I'll just briefly explain this. So directed angles basically you're looking at angles in a particular direction. So for example, AHB. I'm just going to looking at this in the anti-clockwise direction. So this angle here in that direction is, let's say this is 30 degrees. So in that case, we'll say BHA is 30 degrees. But if we look at it from the anti-clockwise direction, so you get that this is going to be a negative direction. So just get a negative angle. So this is very useful when looking at circles, especially if you're not sure of like which points should lie between which points. So if you just want to ignore all those random positionings, then it's good to go with directed angles. So the interesting part here is that the circle theorems work very well with directed angles, and that's the major stuff we need. And also some of angles in a triangle and some angles in a straight line also work very well. So if we get to that, I'll just explain more. All right, so what we have now is, if you look at angle, we're going to try to prove something. So look at angle ABC. So looking at it in a particular direction, I prefer the counterclockwise direction. So ABC, just to illustrate. So it starts from AB to this. So this is in the right direction. So this is actually positive in this diagram, but you could have gone in a different way. Okay. So if you look at this, it's going to be the same as based on circle ABCH. So ABC is part of some bigger circle ABCH. So if you pick any 3 points that are not all of the same color, then they will lie on a circle, just from what we did. The only problem is when we have 3 on a circle, then there's going to be an issue because all the circles we have always pass through exactly 2 points of green colors and 2 of purple. So once we have 3 points, then that's when we have an issue. So once we pick, so we'll be focusing on the purple in a different way as for the green. Okay. So this is equal to AHC. So in directed angles, look at the angle AHC. So going in the counterclockwise direction, that actually goes all the way like this. So in directed angles, 180 is considered to be equivalent as 0. And that's majorly because of the idea of a straight line. So HC is basically considered here as a line. So if you want AHC, so it's where the angle between line AH and line HC. So the first time it meets this, it's actually here, which is going to be equal to this angle, external angle at one point and the other. So this just worked very well. So the way we could just see it, once all 4 points lie on the circle, Then once we pick any three to form an angle, we can just change only one to the fourth. Then we still have equality. So the same actually applies when we look at something like CDA. Sorry, CDA. So that gives you the same as, so CDA, definitely this is purple, this is green, so definitely there's a circle there. Let's just check it. So C, so we have C here, DA, so F, so we have F, so we just change D to F, and then we have equality. So these two are equal. Now let's look at this sum. ABC plus CDA plus AHC plus CFA. Okay, so let's take this sum. So we're just gonna discover some very nice stuff here. So this is an efficient way of going about it. You could just explore lots of angles and come up with the right equation. So we're going to split ABC. Let me erase some of this. Okay. So ABC, we can split that up into, so we have from ABC, so we're going to relate this back to G. So we're going to try to relate this to G, or yet another purple color. So we can write this as AB, so ABG plus angle GBC. So basically, to get from, sorry, I have the wrong diagram. Let's do this again. So sorry about that, ABG, we had this. So we're looking at it this way. So now ABC, just to explain more, in the anti-clockwise direction. So if you go like this, it's the same as, going all the way to G, and then coming back to from G to C. So it's kind of like a vector stuff. So when you do this, if you add those two, you see that you just get back to the same angle. So you get back from AB to BC. Okay, so that's just the trick we'll be using. And we'll be using G as the central point for all this. You could use E as well, but let's make use of G. So we have, so that's just for this. We can quickly write the same stuff for the others. So just split G. So that's for CDA. So we have GDA, and then just continue this way. So from A we get to G first, then from G we get back to C. Then for the final one, from C we get to G first, then from G we get back to A. Okay, so if you look at ABG, if you look at ABG, that lies on circle ABGD, right? So we'll just check for something like ADG or GDA. So here we go. So you see that we can pair this up. We have that ABG is equal to, since the line on the circle is just going to be the same as ADG, which is the same as negative when you go in the backwards direction. So you see that once you add these two up, like they kind of cancel out. So let me use a particular color to strike that. So these two will cancel out. And if you look at GBC, so GBC, so we have F there. So just look for F somewhere else. So yeah, we have these two cancel out. So just go ahead with that. So these two cancel out. Now, if you look at CDG, CDG, so you have H lying on that circle. So look at GHC somewhere. Yeah, here we go. So that will also cancel out. So sums to 0 or 180, so or equivalent. Then we have the last one also just work well. But symmetry is already complete at this point. So everything actually just nicely cancels out. So this is one of the nice properties about taking taking directed angles. So this is the same as 0 degrees. So what this means is that this all sum to either 0 or multiples of 180. So on the other hand, if you look at ABC, it's the same as this, and this is the same as this. So in fact, 2 times ABC plus CDA is 0. So this, in fact, is like the main condition for this. You can write this in a better way, which is 2AC is the same as 2. So if you take this to the other side, it becomes negative CDA, which is same as 2 ADC. So basically, if you start with it works like this. So if you start with any two points, let's say with 2 purple points, and you place any green point here, let's say B, then it's going to give you the same value by placing any other green point. Remember, we already had from this circle here, we already had A, H, C, and in fact, you could trace that we have here, A, F, C. So it means once we start with any two purple, then we can place all the green in the middle and we get exactly the same value. So that's very handy stuff to do. So next is to interpret what this means. So what's the interpretation? This interpretation will help in construction and also in solving the current problem we're dealing with. So so just write what we did here, just in a simple way as like this. Okay, so we have so many of these equalities going on. Okay, so that just means they are equal as directed angles. Interpretation could be that they sum to 180 or that they're actually equal. But mind you, we cannot divide this by 2. So division doesn't quite work very well. And that's because if you consider 180, which is you say is equivalent with 0, dividing by 2 now will give something that doesn't really make sense. So multiplying by 2 is okay, but dividing by 2 is not. So we cannot divide by 2. So these two angles can, in fact, should not be equal, because if they were equal, that would mean ABCD was actually a circle, which was prohibited in the question. So that means, in particular, what we actually have here, in particular, what we have is, so what we have is that 2 into these angles, let's say, let me just write it this way, is 0, right? So this means this could be just 180 times some k, really. So it could be 180, it could be 360, it could be minus 180, whatever. So so what happens is when you now divide by 2, it takes the form of 90k degrees. Okay, so if k is odd, if k is even, this will become 0 if k is even. But we said it cannot be 0 because, let's see, so it cannot be 0 because ABCD is not cyclic, so it cannot be 0. So that means it can only be, k has to be odd. And when K is odd, this will be equivalent to 90 degrees always. So in fact, this difference here is equivalent to 90 in directed angles. Okay, so now how do we get into the center? So let's see how the center comes in. So this actually brings the center quite nicely, because if you observe this formula here, 2 times this angle, which is for a circle ABC, that angle at B, if you multiply that by 2, that relates to the center of that circle. So we have the center here, this angle here, and the one at the center becomes twice of the other one. So if we go from this perspective and look at ADC, for instance, so ADC, so this circle here, center is somewhere here. But look at, sorry, ADC, I got the wrong circle, this circle here, so center is somewhere here. ADC, look at ADC, we have angle D, this angle here. So going in anti-clockwise direction goes like this. It's going to be, multiplied by 2 is going to be the same as the angle here at this center. So twice this. So this is theta, this will be 2 theta. And then this will be also 2 theta in essence. But this one will be basically theta plus 90 degrees from what we just deduced here. Yeah, so the main stuff here is that now we can relate properly that basically the condition comes down to their centers, right? So this is 2 theta, meaning that going from this to this will be minus 2 theta. So if you add the angle here and the angle here, then you get just get 0. So let me write this in a different way. So let's say we call this here I, we call this J, the 2 centers. So this first bit here is just simply AIC. And the other bit is simply AJC. So these two being equal just simply means that AIJC is cyclic. So that means AIC and the other center all lie on the circle. And not just that. If you look at the perpendicular bisector of AC, so of these 2 purple points, so it's going to pass through both I and J. And AI will be equal to CI, AJ will be equal to CJ. So in fact, this is a very symmetric figure. So we get right angle at A and C. So IJ is basically the diameter of the circle that passes through A and C and IJ. So in fact, that's how we construct this. Okay, so I'm going to construct these centers now. So we can construct the centers by taking perpendicular bisectors. So, but I'm going to take them in a particular way that will make it as efficient as possible. So we'll draw as few lines as possible. So we're just going to draw perpendicular by, so any triangle that leads to this sort of center, you have 2 points of the same color and a point of a different color. Okay, so I'm going to make things as balanced as possible. So for example, let's say we had A, B, C, right? Instead of taking the angle bisector at AC, since we need one more bisector, I'll just go ahead with AB and BC, so different colors. So I'm just going to now draw all the possible bisectors starting from A with any other green color. So I'm just going to draw that first. We'll sort things out after that. So we already drew for B, so we have that. Then move on to C. So with all the green ones, we already have for B, CH, CF, CD. And then you start noticing some interesting stuff going on. So you look at E, you have EH, so I have EH, EB, ED, EF. And then for G, we have EB, GB, GF, GH, and GD. Okay. Now the points we want are going to be some kind of intersections of certain angle perpendicular bisectors. If you observe, you see that there are certain points that are the intersection point of exactly 4 lines. So, and those points are actually the points we need. Those points are the points we're looking for. Okay. So I'm going to first draw, just plug in those points, and we'll explain why they are indeed the centers. So we're expecting 12 points, by the way, because we have 12 circles. So far we have 5. This one here, 6, 7, 8, 9, 10. So we might have to zoom out to see more. 11, should one more. Oh yeah. So down here, 12. Okay, so you can zoom back in. All right, so those are the centers. Now, as for why they all pass out like differently, the center of a circle, which contains 4 points, A, B, C, D, A, B, C, H, right? A, B, C, H. Now, if you pick any purple and green pair, that would must have drawn that perpendicular bisector. So you see that you could go with AB, AH, or CB and CH. So we have exactly 4 of them, and they all pass through I. So it makes perfect sense. So in fact, every center must have at least 4 of those lines. And if it has 4 of those lines, we can also argue that it's the center of some circle. So with this, that means definitely we have all the centers we need. We'll talk about these lines a bit more later on. But just to conclude this video, this point, so I'm going to just hide some of these lines for now. Just hide these lines. I think that's pretty much everything. All right, so when you hide those lines, you get this figure. Now, if you remember for I and J that we did before, we actually have a circle. And that circle, we use that circle as like our model to understand what's happening. So the circle now passes through 2 purple points. And then we have I and J. So we already talked about this. So in a sim, for every 2 points we pick, the way we pick A and C, so for every 2 points we pick, we're going to get 2 points of the same color. We're going to get 1 circle. So if you analyze this, that means from all the 4 purple points, you can choose 2 points in 4 choose 2 ways, which is 6 ways. So altogether, I'll be getting 12 circles, 6 for purple and 6 for green. Okay, so just gonna go ahead and draw them. I think there's something wrong with the L. Probably I placed the. We'll look at that. Okay, we have this one. We have think. So just focus on all the purples first. We have this. We have this. I think. I'm not sure. Probably not that. So if we bring back all those lines, it may not be as complicated. I don't think this is the right one. Let me zoom out for a bit. Okay, so looking at this. Okay, oh, it's the right one. Okay, so pick remaining G and E for the last couple pair. What's that gonna be? Okay, so now there are some, I think I got some points wrong. So let's do this again. So there are 7 points that, let me move something. Let me move it around for a bit. So there are certain points that I didn't thought very well. Okay. Yeah, so L and N are not the right points we are looking for. Let me see. Yep. So N, okay, so just bring back 2 of those lines. So around we have, I'm going to delete L and N and place them in their right positions. Okay, so this should be okay now. All right, so yes, so that's what we have. So I think we should be able to properly draw these figures now. So let's just continue the last one, the last purple circle is C and G, and that should pass through here, I believe. That passes through P. So we'll have to zoom out to make sure it passes through yet another point at some extreme. Well, there should be one more point at some extreme. Yep. So there we go. Okay. So those are the I'm not sure if this is all the circles I wanted to draw. Let's see how many circles we have. So we're just going to paint all these circles purple. Or we're just going to use purple. This. So we have 3 so far, 4, 5. So we need one more. Yeah, we need one more. Okay, so I saw some points that we've not drawn. What are we missing? I think that should be for AE. So let's draw for AE. So we have just gonna do this. Yeah. So that's the last bullet point we need. Okay, that's purple. Now, in a similar way, we could just do the same for green. So just pick any pair of green points and figure out the right circle based on how they look. We could have used the angle perpendicular bisectors to do the job, but too many lines, so try to avoid that. By the way, let me erase some of this stuff. I don't think we need this anymore. So just gonna erase all this. Okay, so circles. So D, B, D, F, and B, H, E, H. I'm not sure which one. Okay, I is there. Yeah. Okay. Then B, F, K, and F. Yeah, I think that should be all. All right, so let's just color all this green. So I'm just gonna use these colors to highlight where they're coming from. So they behave a bit differently from the other colors, from the other circles. So just use this to differentiate. So we have 4 now, 5, yeah. So we have all we need. And to confirm, we just observe that every center will have 2 circles passing through it, so 2 different colors. So if you look very well, so let me zoom out the last one. There's much one beyond. Okay, so T, yeah, T works well. M, L, R, K, O, I. Okay, so all these are working very well. So I'm going to just swipe for the next one. Into this orange. This orange. There's 2, 3, 4, 5, 6. So it can be argued that we can have more than these circles. I'll talk more about that later on. So, but these are the circles that we do have. Okay. One more. Okay, yeah. Okay, so here is what we have. This is also orange. Okay. Yeah, so that's what we get. These are the circles. And as a matter of fact, some of this, it's not hard to show that you don't have circles through them because some of them are actually collinear. So remember, for example, there is an angle here. You just highlight that. So you see that it's going to pass through 3 of those centers. That's because if you pick, let's say A and B, this is perpendicular bisector of A and B. So when we pick A and B, see that it forms a circle with DG, HC, and also the other ones, which is F. That should be FE. Okay, so because that's having that circle, those 3 circles is being collinear. And there are actually much more circles involved in this, which will show that we have more than we have currently. So we're going to see a bit more about that in the next level. So make sure to like and subscribe. I'll see you in the next one. Bye-bye.